Means we're putting back together and we're fixing without parts from Bugatti, and we've already done and accomplished what we were told couldn't be done, which is give us confidence.
What if everything the experts said was impossible was actually wrong? That is the question that started one of the most shocking rebuild stories in the modern car world. A Bugatti Chiron Sport, one of the rarest and most powerful hypercars ever made, sat heavily damaged in a quiet garage. It was not just scratched or lightly broken. It was completely wrecked, with serious structural damage that most people would never even attempt to fix outside a factory. According to the common belief in the automotive world, cars like this are not meant to be repaired in small workshops. They are meant to go back to the manufacturer, be written off, or broken for parts. But this story was different. It was about a man who refused to accept those limits. Mat Armstrong, known for his extreme car rebuild projects, saw something others did not. Where experts saw a dead end, he saw a challenge. This was not just about fixing a broken car. It was about proving whether skill, determination, and engineering thinking could beat factory-only rules. The situation quickly became more than just a repair job. It became a test of belief. Could a small team in a regular garage really bring back a multi-million-dollar hypercar that even the manufacturer said needed special facilities? Or was this truly impossible? That question alone was enough to capture the attention of car lovers around the world. The story truly began when the Bugatti Chiron Sport was involved in a severe crash. This was not a small accident. The damage was massive and shocking. The front end of the car was heavily destroyed, and key structural parts were bent or broken. The aluminum frame, which is one of the most important parts of the car, had been damaged in a way that made the vehicle unsafe to drive. Even the gearbox area had been affected, making the repair even more complex. In most normal cases, insurance companies would simply declare the car a total loss. For many people, that would be the end of the story. But this was no ordinary car and no ordinary situation. The Bugatti Chiron Sport is one of only a limited number ever built, making it extremely rare and valuable. Instead of giving up, the owner and Mat Armstrong saw an opportunity hidden inside the wreckage. At the same time, Bugatti itself stepped into the situation and made their position very clear. They explained that the car required specialized repair facilities, and only a very small number of locations in the world had the right tools, training, and approval to handle such a job. The company warned that trying to fix it elsewhere could lead to serious safety risks. This warning was not small talk. It added real pressure to the situation and raised the stakes even higher. Now, it was not just about fixing a car. It was about proving whether those limits were truly necessary. Despite the warnings, Mat Armstrong made a bold decision. He chose to take the challenge. After negotiating and buying the damaged Bugatti, he brought it into his own workshop. This moment changed everything. It turned a factory-level problem into a garage-level experiment. The car was carefully lifted and placed in a working space, where ordinary tools replaced factory machines. From the very beginning, the project felt different. Every part of the car had to be studied carefully. The team began stripping the vehicle down, removing damaged panels, checking internal systems, and inspecting the full structure. What they discovered made the challenge even more serious. The damage was deeper than expected, with hidden issues appearing as they worked. Every bolt, every wire, and every connection had to be handled with extreme care. One mistake could make the situation worse. But instead of fear, there was focus. Mat and his team approached the job step by step, carefully documenting everything. People online began to watch closely. Some believed it was a genius move, while others thought it was impossible and dangerous. The internet quickly turned this rebuild into a public debate. Could a garage really compete with Bugatti? Or was this just a risky experiment waiting to fail? This tension became a key part of the story, making every update more intense. Than the last point. One of the most important and dramatic stages of the rebuild was when the team decided to split the Bugatti Chiron into two halves. This is something that normally only happens inside highly controlled factory environments. Bugatti uses special lifts, tools, and procedures to safely separate the front and rear sections of the car. Doing this allows access to the engine and gearbox for major repairs. But in Mat's workshop, there were no factory machines, only standard garage equipment and a skilled team. The process required extreme care. First, All wiring systems had to be disconnected. Then fluid lines for oil, coolant, and brakes were drained and sealed. Every bolt had to be removed in a specific order to avoid damage. The carbon fiber structure of the car made the job even more delicate because it is both strong and fragile at the same time. As the work continued, small problems appeared. Hidden fasteners, tight connections, and unexpected design challenges slowed progress at times. But the team solved each issue step by step. After days of careful work, the moment finally came. The car was successfully split into 2 clean sections. It was a shocking sight. A hypercar worth millions, now sitting in 3 parts in a normal garage. This moment proved that with patience and skill, even the most complex factory procedures could be challenged outside their normal environment. After the split, the full damage became much clearer. This was one of the most critical moments in the entire rebuild. The engine had been pushed forward during the crash, causing serious internal stress on surrounding parts. The gearbox mounts and engine supports were heavily damaged, with cracks running through key areas. These mounts are extremely important because they hold the heart of the car in place. Without them, the engine cannot function safely. The team carefully examined every detail. The good news was that the main engine block itself was still intact. The internal components were not destroyed, which meant the heart of the car could still be saved. But the supporting structure was in very bad condition. This created a new challenge: how to repair or rebuild parts that are normally produced with factory precision. Every decision now mattered more than ever. The team had to decide whether to weld, reinforce, or completely rebuild certain sections. There was no guidebook for this situation. Everything depended on experience, logic, and careful testing. At this stage, the project shifted from simple repair work into serious engineering problem solving. It was no longer just about fixing damage. It was about rebuilding strength and safety from scratch. The next major challenge was the welding and reinforcement process. The damaged engine and gearbox mount was made of cast aluminum, which is very difficult to repair. Aluminum reacts badly to heat if not handled properly. Too much heat can weaken it, and too little can make the weld fail completely. The team first performed a weld test to check if the material could even be repaired safely. Once they confirmed it was possible, the real work began. A skilled fabricator carefully started welding the broken sections together. Sparks flew as metal was slowly rebuilt. Every movement had to be precise. At the same time, Matt insisted that the repair should not only restore the part, but also strengthen it beyond its original condition. Additional reinforcement pieces were added to improve durability. Each weld was inspected closely to ensure there were no weak points. During this process, small setbacks still happened. A bolt snapped due to incorrect torque, reminding the team how delicate the job was. But they adapted quickly and continued working. This phase showed the true nature of the project. It was not just about fixing damage. It was about improving engineering under pressure. The garage was becoming a place of innovation, where problems were solved in real time with skill and creativity. After the structural repairs were completed, the team moved on to reassembly. This was one of the most exciting and stressful stages of the entire project. Every part of the car had to be carefully reconnected. Wiring systems, fluid lines, sensors, and mechanical components all had to work together perfectly. A single mistake could cause major failure. The team worked slowly but carefully, double-checking every connection. Once everything was in place, the moment of truth arrived. Matt sat in the driver's seat, took a deep breath, and pressed the ignition button. In seconds, the powerful W12 engine came to life. The sound filled the garage, confirming that the rebuild had worked at a basic level. The transmission engaged smoothly, and all systems responded correctly. This was a huge milestone. It proved that a heavily damaged hypercar could be fully disassembled and brought back to life outside a factory. The reaction was immediate. People online were shocked, excited, and impressed. What many believed was impossible had now been achieved at a functional level. The garage had successfully done what only official facilities were supposed to do. Even after success, the project was not over. The rebuilt Bugatti still carried risks that needed careful monitoring. Cooling systems, structural alignment, and electronic sensors all required constant testing. Hypercars like this depend heavily on advanced electronics, and even a small fault could cause serious issues. The team continued checking temperatures, recalibrating systems, and testing performance under controlled conditions. There were still concerns about long-term durability, especially in areas that had been welded or reinforced. Every test drive had to be done carefully, with full attention to safety. At the same time, the project had started to influence the wider automotive world. People began discussing whether independent workshops should be allowed more access to repair high-end vehicles. The rebuild became more than just a YouTube project. It turned into a conversation about repair rights, engineering freedom, and manufacturer control. Many saw it as proof that skilled independent builders could achieve results similar to factories. Others remained skeptical. But one thing was clear. The conversation in the car world had changed as time passed. The story of the Bugatti rebuild grew beyond a single project. It became a symbol of what determination and engineering skill can achieve. Workshops around the world began studying the methods used in this rebuild, from welding techniques to structural reinforcement ideas. The impact went beyond just cars. It inspired a mindset of questioning limits and challenging assumptions. What started as a wrecked hypercar in a garage had turned into a global story about possibility. It showed that while factories may set rules, innovation often happens outside of them. The rebuild also highlighted the importance of teamwork, patience, and problem-solving under pressure. Every stage of the project carried risks, but also lessons. In the end, the Bugatti Chiron Per Sport was not just repaired. It was transformed into a statement. A statement that sometimes the word impossible is just a challenge waiting to be tested. As the rebuilt Bugatti Chiron Per Sport continued to be tested, the attention around it only grew stronger. What had started as a private garage project was now being watched by millions of people across the world. Every update felt like a new chapter in a live engineering experiment. The car was no longer just a damaged hypercar brought back to life. It had become a symbol of challenge against established limits. However, behind the excitement, there was still serious caution. The team knew that one successful engine start did not mean the car was fully safe or permanently reliable. Every system still needed long-term validation. The suspension geometry, the electronic stability controls, and even the smallest wiring connections had to be monitored closely. In a car like this, everything is connected, and even a tiny mistake in one area can affect the entire machine. Matt and his team approached this stage with patience. Treating each test like a critical step in proving the rebuild was not just temporary success, but real engineering stability. They drove the car in controlled environments, carefully checking temperatures, listening for unusual sounds, and inspecting every part immediately after use. This slow and careful process showed that rebuilding a hypercar is not just about making it run. It is about making it survive real-world stress over time. Every mile driven became a test of trust between the builder and the machine. One of the most surprising discussions during this stage was about the use of non-standard parts in the rebuild. In a project like this, not everything comes from official Bugatti sources. Some components were repaired, while others were modified or adapted from different vehicles. One of the most talked about details was the use of a starter motor originally sourced from a Volkswagen Polo 1.9 TDI. This detail shocked many viewers, because it showed how even the most advanced hypercar systems can sometimes rely on simple, widely available parts. However, this was not about cutting corners. It was about problem-solving under extreme conditions. When factory parts are not easily accessible or when replacement options are limited, engineers often find creative alternatives that still meet performance needs. The team carefully tested every adapted component to make sure it could handle the demands of a high-performance engine. This approach highlighted an important truth in engineering. Perfection is not always about using the most expensive parts, but about making systems work reliably together. Still, every modification carried risk, and each change had to be verified multiple times before the car was considered safe. This balance between creativity and caution became a defining feature of the entire rebuild process. As the project progressed further, its meaning began to shift beyond just a single car repair. What started as a technical challenge slowly turned into a wider discussion about the future of car repair and ownership. Many people began to question why such complex vehicles were restricted to only a few official repair centers in the world. The Bugatti Chiron Per Sport rebuild became a real-world example in this debate. If a small garage could successfully rebuild such a complex machine, then what exactly were the limits of independent workshops? Supporters of the project argue that skilled engineers should have more freedom to repair and rebuild advanced vehicles without strict manufacturer restrictions. They believe that innovation should not be locked behind corporate control. On the other hand, critics argue that hypercars require extremely precise engineering standards, and even small mistakes could lead to dangerous outcomes at high speeds. This disagreement created a larger conversation that went far beyond YouTube content. It touched on safety, responsibility, access to technology, and the balance between control and freedom in modern engineering. The rebuild had unintentionally become part of a global discussion about how far independent engineering should be allowed to go in the automotive world. Despite the growing attention and debate, the team behind the rebuild stayed focused on their main goal, making sure the car was truly reliable and safe. They knew that public attention could sometimes create pressure to rush results, but this project required patience above all else. Every system was rechecked multiple times, from the engine mapping to the brake response. The chassis alignment was measured repeatedly to ensure that the car would behave correctly under load. Even small vibrations during testing were investigated carefully, because in a hypercar, even the smallest irregularity can grow into a serious issue at high speed. The team also spent time reviewing data logs from each test run, analyzing temperature changes, pressure readings, and electronic feedback. This data-driven approach helped them identify potential weak points before they became real problems. It showed that modern car rebuilding is not only mechanical work, but also digital analysis. The combination of hands-on engineering and technical data monitoring was essential in making sure the rebuild was not just visually successful, but functionally sound. Every step forward was measured carefully, and every improvement had to be confirmed before moving on to the next stage. Over time, the Bugatti rebuild began to influence how people think about damaged hypercars in general. Traditionally, when a vehicle like this is badly damaged, it is considered beyond repair outside of factory environments. However, this project challenged that idea by showing that with enough skill, patience, and understanding of engineering principles, even extremely complex machines can be restored in unconventional settings. This did not mean that factory-level expertise was unnecessary, but it did raise questions about whether such expertise must always be limited to official facilities. Many engineers and enthusiasts started analyzing the methods used in the rebuild, studying welding techniques, reinforcement strategies, and structural repair approaches. Online communities began discussing how similar methods could be applied to other exotic vehicles. In this way, the project became more than just a single success story. It turned into a learning example for a wider audience. It also inspired many young engineers and car enthusiasts to think more deeply about how machines are built and repaired. Instead of seeing damaged cars as finished products, they began to see them as systems that could potentially be understood, repaired, and improved with the right knowledge and effort. In the end, the story of Mat Armstrong's Bugatti Chiron Per Sport rebuild is not just about one car or one garage. It is about pushing boundaries and questioning assumptions that have existed in the automotive world for years. What made this project so powerful was not only the technical achievement, but also the mindset behind it. It showed that determination, careful planning, and hands-on problem-solving can sometimes challenge even the most established systems in the industry. At the same time, it also showed that such work carries real risks and requires deep responsibility. This was not a simple repair. It was a complex engineering journey that tested every skill the team had. The final result became a symbol of possibility, showing that what is often labeled impossible may only be limited by current systems and beliefs. The rebuilt car stood as proof that innovation can come from unexpected places, and that progress is not always controlled by large institutions. Instead, it can also come from small teams willing to take risks, think differently, and refuse to accept limits without question. As the rebuilt Bugatti Chiron Per Sport moved further into testing, the attention around it kept growing, but so did the pressure to ensure everything was genuinely correct. At this stage, the car was no longer just a rebuild project for content or curiosity. It was a fully working hypercar that still carried a history of a major crash and a highly unconventional repair process. That meant every single drive mattered. The team treated each test like a serious engineering evaluation rather than a normal road experience. Speeds were gradually increased. Systems were checked repeatedly, and every unusual sound or vibration was taken as a potential warning sign. One of the biggest concerns was how the repaired structural areas would behave under real stress. Even if a weld looked perfect, and even if reinforcement plates were strong, the real test only comes when the car is pushed under load. The suspension system, which connects the car to road, had to absorb forces from acceleration, braking, and cornering without showing any weakness. Engineers and the team paid close attention to alignment data after every run, because even a small shift in geometry could suggest long-term instability. This phase of the project showed a very important truth. Rebuilding a hypercar is not just about fixing visible damage, but about understanding invisible forces that act on the structure during real driving conditions. Another important aspect of the ongoing testing phase was the behavior of the electronics. Modern hypercars, like the Bugatti Chiron Sport, are not just mechanical machines. They are highly advanced digital systems. The engine, gearbox, traction control, suspension adjustments, and safety features all depend on complex electronic communication between multiple control units. After a major rebuild, even if everything is physically repaired, the electronic systems can still behave unpredictably if something is slightly out of calibration. The team spent a significant amount of time monitoring sensors, checking wiring continuity, and verifying that all signals were being interpreted correctly by the car's control units. This included engine temperature sensors, wheel speed sensors, throttle response systems, and gearbox communication lines. A small fault in any of these systems could lead to incorrect performance adjustments or even safety risks at high speeds. That is why the testing process was slow and methodical. Instead of rushing the car back onto the road, each system was validated step by step. This careful approach showed that modern automotive engineering is a combination of mechanical skill and digital precision, without both working perfectly together. Even the strongest physical rebuild cannot guarantee a safe and reliable vehicle as time passed. The story of the Bugatti rebuild began taking a life of its own beyond the garage. It was no longer just about Mat Armstrong and his team. It had become a global talking point in the automotive community. Enthusiasts, engineers, and even critics were discussing the implications of what had been achieved. Some people saw it as a breakthrough moment, proving that independent